Welcome to Math 104, where we're talking about average error and we're getting ready for regression week. So somewhere on your page, label this sheet as average error, somewhere big at the top so that when you go back through your notes, you know what you're looking for when it asks you on your project what the average error is. Your homework doesn't ask it, but your project certainly does. So first things first, we will be working in this case with a TI-84. So for those who have been working with an 84, that's really great. We're also going to be doing regressions with Desmos if you would like. That's going to be kind of up to you guys on how to enter that in. I prefer an 84. I think it's really easy. Once you get it down, the steps are the exact same each time. And all you have to do is just change one button each time. So with average error, we're going to start very small. First thing we want to do is prepare the calculator. So going ahead and clearing out everything. Now these notes are sometimes a little old. What I like to do when I go to clear your screen, and you only have to do it once for today. You don't have to do this every time, but it does help us keep our screens or our computers, our calculators running nicely. I like to hit second plus sign 712. This will clear everything out. It'll start you with like a brand new calculator. Now, once we do that, we need to make sure that we're turning on your scatter plot by hitting second y equals, having that first plot, and we're going to switch it to on. This will turn on scatter plot. This is like the first thing that you want to do. You don't have to do it every single time, but if only if you have been messing around with your calculator a lot. So let's go ahead and turn that on. So you'll notice I have a blank calculator. I've already reset it. So now I'm going to hit second y equals. I'm going to go from that first plot and I'm going to switch it back on, making sure I hit enter. You can change color, whatever you want, just as long as the type is selected on scatter plot. You have list one here and list two. Your list one is your X values, list two is your Y values. If you were to switch them, this is where you can kind of come to correct your mistake. So let's go hit second mode to just go back to a cleared screen. So make sure everything to start, everything has been cleared out. So your lists, your y equals, so no equations in there, and you're just starting clean. Now you're going to be given a set of data. So to enter, number 2, enter data. We're going to be selecting stat, edit, and then the first edit to enter. So if you don't know where stat is, it's right below your delete button, and delete is right below your zoom button. So kind of in the upper middle part. So we hit stat, edit. You're going to see that first one at the very top, and then the number 1 edit. We're going to be entering that. So your lists are nice and clean. We want to make sure everything says list 1, list 2, list 3. So we have that available to us. Now we're going to enter in your X values. Now there you've told us here that your X values are the values from 1 all the way through 5. So number 3, enter in X values to list number 1. So some of you might still be up here in pink where it's on your list. We will be doing that later on in this video, but when you enter in your data, we're wanting to be on that first cell. And each time you enter a new number, just hit enter. We're going to do that all the way until we get to 5. We move over and we're going to be entering in your Y values in list 2. So your Y values, we're moving over here. We say enter in your Y values. So these being 6, 8, 12, 14, and 18. Now these are your actual Y values that the data is producing. So step 4, enter in Y values to list number 2. We said we have 6, 8, 12, 14, and 18. Now double check that all of your values are the exact same in the right spot. So 4 goes with 14, 3 goes with 12, 2 goes with 8, and so forth. I just want to double check on my end. Those are fine. Now your sheet tells you to then generate the regression function, but I would like you to take a look at your graphing calculator next. So step 5, look at the graph to determine the regression shape. So could this be more in a line? And we want to click a line regression, or does it look like a parabola where we click a quadratic, or does it look like a logistic function, right? So the shape is going to really have an impact on which regression we're going to be choosing. So let's go ahead and hit second mode. Let's see, and let's go ahead and hit second graph. Oops, not second graph, just graph. So you'll see 2 data points, but we know we have 5 data points. So in order to get the remainder, we're going to have to shift around your Y and X values. So going over to window, again, notice that your X values, if we were to build a window for your X values, we're only going from the values from 1 to 5. So when we talk about your window, your X minimum, we don't want to start right on 1. So maybe perhaps 0 or -1. In your X max, our values stop at 5, but we don't want to be right on 5. We want to be just a little bit ahead so we're not stopping on a data point. So 6, 7, 8, something that's a little bit further out. So maybe we do 8 in this case. Same thing with your Y values and your X scale, because they're so small, we could go up by half, we could go by 1, whatever you're feeling. Let's do the same thing for your Y min. Your Y minimum, we said, starts at 6, get lower than 6. Maybe we go to 0 in this case. Y max, we go all the way up to 18. Don't stop on 18, go a little bit further. Maybe I go up to 25. And your Y scale, we don't have to go crazy. You can go up by maybe 2s would be okay. 1s, don't go wild. So we said maybe a -1. If it comes up with a syntax error, make sure you're hitting, if you're using negative values, you're using the negative button. We said we're gonna perhaps go up to 8. If you wanted to go to 10, there's no stopping you, that's okay. We can do it here. We said we are gonna start at 0, go up to 25, maybe going up by 2s. And let's go and graph. So here we have your data values. All of them are accounted for. And what kind of shape does this look like? Well, this to me, it's not exactly a line, but they are kind of shifting into a line formation. There's no real curve about it quite yet. In the future, we can try and fit curves on there, but let's, for right now, just assume that these look like a line. Let me move that over. So these kind of look like a line. So in order to make a regression, what we're going to be doing is getting the regression to pop up. So all of our particular lists. So do we want a line for a line reg, or a quadratic for a quad reg, or a cubic for cubic reg? So things like that. Now, before we move on, there is something that I want you to turn on, and that would be your correlation coefficient. And we'll talk about that in a moment. So turn on the little R, correlation coefficient. We're going to hit second 0, and we're going to go all the way down until we see diagnostic on. Now mine already does that, so I'm just going to show you where to go. You're going to hit second 0 for that catalog, and all the way down here, it's going to tell you all of the things that your calculator can do. You're going to be continuing to find where it says, of course, it doesn't have it on here. There should be one here that says under distribution, or actually on top of distribution, it should say diagnostic on, and then below it, diagnostic off. This particular app already comes with it, so you don't need to do it. But you're looking for diagnostic on, and you're going to hit enter twice. Make sure it's actually turned on. Because if you don't have it, you're not going to see R and R squared, which we're going to talk about here in a moment, play a big factor. So in order to get the list of regressions, we're going to go back to stat, going over to calc, and then you're going to scroll down. Now, scrolling down, you're going to see a lot of different options. You have a whole list of options. Now, what we're going to be doing is the one that's number 4, lin reg. We said, hey, ours are kind of in a line shape. This is the one we're going to use. All right, so lin reg, we have, it's just asking here, do you want your X values to be in list 1, your Y values in list 2? Yes, we do. Again, if you switched it on accident, you can switch it here. Now we're going to go down to store reg EQ. This is where we can store whatever our equation is into this Y equals area. This allows us to skip a big step where we have to punch the equation in, to be more specific. So what we're going to do, we're going to go over and hit vars. Vars is right under or right next to the clear button, kind of sitting up on tangent. So we're going to hit vars, going over to Y vars, that first one function, and then this is just saying, where do you want this equation pre-stored? Let's just put it in this first one, Y1. If you're comparing, you can click Y2, 3, 4, however many equations that you want to store. Okay, so now that it's in there, we're going to go ahead and hit enter. And notice that R squared and R have popped up. We'll talk about that in a second. So now this is our equation. Now this is a nice equation because it is so simple. You could easily type these in. But when it comes to our modeling examples and our project, they're not going to be very easily typed. Students make a mistake each and every time they go and type in an equation. So using that storage button or series of buttons is really going to prevent accidents from happening. So this first one, it says y equals ax plus b. Well, that is going to be our outline. So we can actually determine a below is 3. So we have 3x plus b is 2.6. Oops, coming. So we have that there. So when we put it together, this should read y is equal to 3x plus 2.6. If it was a negative 2.6, we could say minus 2.6, but this is the equation. This is what is going to be stored in your y1. So if you have y equals y1, we said, hey, this is where we're storing it. And then we can go ahead and hit graph. Now notice that this graph, right? You're trying as much as you can to get this line to fit your data points exactly. Now, is it a perfect fit? No, it's not. It does come close, but every time that it's not going through the center is going to be considered a miss or some error, right? So the average error is what we're going to be looking for today. Now that average error, because we said, hey, it's not quite a perfect fit. And if we wanted to know, well, how perfect is it? Instead of r squared, let's take a look at r. We have 0.9934. We're going to round that last one. So we like to round to 4 decimal places on this R. What did we say? 9934. 9934. This is your correlation coefficient. Now, this R is telling us how closely the line is going to get to your data points. So in order to be perfect, when R is perfect, it will be a perfect 1 or a -1. -1 being it's just a line that's sloped downward, so it's decreasing, and ours is positive, so it's increasing. So the closer this value is to 1, the better the fit. We said ours isn't a perfect fit, but it is a pretty good fit. So anything that has a 0.99, the more nines you got in there, the better it is. So it does miss by a little bit. It wasn't so drastic, but the closer it is to the center of those values, the better. Now, if we do a side note, if R square is present and R is missing, we square root R squared to get this value. That is just in case some of these regressions don't come with R, we can then go ahead and square root it. All right, so let's do it. We're going to continue on to the next page for list 3. So this first page here is just how to pick your regression. The next page is to pick the average error. So average error, we start on list 3, and list 3 says, okay, we're going to get those predicted values. These values are coming from the line that we have just put onto your graph. These are not the actual Y values. These are just close estimations. We want to get that line to be as best as possible, to be as close as possible to your data. So it does say in list 3, we're going to take Y1 and we're going to multiply it to list 1. So, and notice where their cursor is in list 3. So we're going to have to go up by this L3 mark and then enter in the following. Now, if you did not enter in your equation and you go here and you skip recording your equation in Y equals, it's not going to work. So always make sure you have these values recorded or your equation is recorded. Be sure to record your equation before going to list 3. So we're going to be hitting the following in list 3. So we're going to hit Stat, Edit.
The 2024 Kia Sportage was built for adventure. Sportage offers unmistakable style.
All right, so we're going to go up to list 3, up here where it's in pink. And we're going to hit vars, yvars, function y1. So we've grabbed your equation that is stored in y1. Then we're going to multiply it. So multiply button, and then parentheses, we're going to hit list 1 by hitting second 1. You'll notice that everything in blue above your numbers is just going to be the exact list. Close your parentheses and then go ahead and hit enter. What this has done is it's taking your X values and it's multiplying it to the equation, or it's entering in these X values into the equation that you've gotten. So now these are your new, quote unquote, new Y values. There we go. For whatever reason, it's not, it does not like when I hit the multiplication button. Okay, so now let's go to list 4. Let's hit list 3 minus list 2. All right, there we go. Now your errors look a lot smaller. So list 4 is going to contain your errors. We want these as small as we possibly can. Okay. So from here, we have your errors, and then we want to find these squared errors. So instead of using list 5, what we're going to do is we are going to hit the following. Where did it go? We're going to go directly to here. And I'm going to highlight all of the ones that we've been using so far. These values here. These are the buttons that we've been pressing. So now let's go ahead and hit Stat Calc. We're going to hit the first one, 1var stats. It just means one variable statistics. And what we're going to be looking for is these two values. Something that says sigma x squared. So this funky looking E and x squared, and your N, how many numbers we have. So we're going to go ahead and hit second mode, Stat Calc, and it's that first one.
New Lyrics. Nationwide helps financial professionals identify their clients' long-term care needs.
Okay. We're going to switch this list to be list 4, that we want to analyze the errors. So making sure it's list 4. Frequency list doesn't matter. We're just going to go ahead and hit enter. And we're going to have a whole lot of numbers that pop up. The only ones we really need is the bottom one where it says sigma x squared, so 1.2, and your N value, which is 5. And we actually want to plug that into your calculator. So we're going to hit square root of 1.2 divided by 5, in which we're going to have this value here of 0.489897. Oh, so let's just round it out to 0.49, which is the amount of error that we have. So the smaller this value, the better. And these are going to vary depending on your data. So notice that our data was kind of small to begin with. We went from 1 to 5 for your X values. Your Y values, we only went from 6 all the way to 18. These modeled ones that we're going to see later on are going to be huge. So while your error is going to look huge, it just means that the amount of space between them is a lot greater than the ones we're going to see here. Now, I do want you to compare what you have here. So this 0.489 number to somewhere else on your screen. What are we seeing? So we're seeing a lowercase sigma x, have that same value. So if you wanted to bypass yet another step, instead of taking the sigma x squared and dividing it by your number of data points, 5, and then square rooting that number, instead we can actually just bypass it and choose this number each and every time for our purposes. So we can go ahead and write that down. So we can use the equation, the square root of 1.2 over 5, or this is your sigma x squared over N, or locate little sigma x. That will contain your answer as well. All right, so one more time, average error is the difference between your actual values found in list 2, your data values, and comparing it to those that are on your graph. So when we go to your graph here, notice that our graph is not perfect. So it's going to have some errors. Now, each and every one are going to touch the line, but they're not going directly through the center, and that's going to cause a small error. Oops, how do I get there? And so the smaller that error is, the better fit the graph is. And that is average error.